morning, dear students. Today we can do the two-way ANOVA problem. First, I will give the working rule for doing the two-way ANOVA problems. By the data, if you read the question, you get it from the data. This is data you are getting from the given question. By the data, you have to analyze that data and write it like this. First step, by the data, you make this column and rows. Look here, the three groups are given. If the three groups are given, you take A, B, C in vertical way. Okay, and this 1, 2, 3, 4, the observations values may be given or more may be given. It depends upon examiner. Then you can enter the observation of A. Here, here. Okay. And similarly, observations given in a question of B. B is observations. First observation, second observation, third observation, fourth observation. You can enter here. And similarly, observations of the C group. First observation, second observation, third observation, fourth observation. You can enter here. Then, now look here, my dear students. Look here, next column is the TI. The TI is sum of all these observations, is TI. And TI square, the square of TI. And this is, you can take a square of these observations and add them, that is summation of xi square. Look here. Now, this plus this plus this plus this. My dear students, you can this plus this plus this plus this. This is the TI. And take a TI square. You take a square of this, you get the TI square. And now the square of this plus square of this plus square of this plus square of this. You can add them. You can get summation of xi square. And next for the B, reading B, this plus this plus this plus this. This is the TI. And take a square of this, you are getting TI square. Again, this square plus this square plus this square plus this square and equal to summation of xi square. You can write here. Okay, for the readings, for the C group, this plus this plus this plus this. You get the TI. And square of this, you get TI square. You can enter here. And this square plus this square plus this square plus this square equal to summation of xi square. Then next, you can add this plus this plus this. You can get T. This is total, the sum of total observations you are getting. Then this plus this plus this. It is summation of xi square. Okay. If you do mechanically, it is very, very difficult to difficult not, but time wastage is more. So that you can do all these things in a calculator with great precision. Look here. Now open the calculator. Open the calculator. You press the mode button. And you press the 3, that is stat. Then number 1 variable, number 2 variables. Now I can use 2 variables. 5 means, look here, this is A and B, we can enter. And all these values are coming. Okay. Now you can press the 2 button. Then in the calculator, X and Y column opened there. In the X column, you can enter all the values of A. And this value equal to, this value equal to, this value equal to, this value equal to. Then you take the cursor upward and bring the cursor to the 1 position and shift the cursor in a Y column. Then you can enter this equal to, this equal to, this equal to, this equal to. and all the 8 readings are entered there. Next, you press the AC button. You press the AC button and shift 1. And I want a sum, so that third button. All the summation values are you are getting. Summation. Look here, number 1, summation of x square. Look here, summation of, see here, this, if you press the number 1, you can get summation of x square. Summation of x square. And look here, and 3, if you press the 3, you can get summation of y square. This value you are getting. Then I want this value. For this, you can press the 2. If you press the 2, you can get summation of x. And if you press the 4 number, you can get summation of y. Look here, all these values you got. Then again AC button and mode button, third button, again 1 button. See, by 1 means, look here, only one the group is left out. That is why you use the only one column. Suppose here one more group is given, you take the second option. Means 2 column you can take. Now you can take only 1 column, enter this equal to button, 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 AC button, again shift 1, start, and again third button. Then you can get summation. Look here, number 1 summation of x square. Look here, if you press the number 1, you can get summation of x square. You are getting, and this summation of x I want, so that number 2. If you press the number 2, you can get the summation of ti. And square, you press the x square button, you are getting the ti square. You can add all these things. Okay. And next, look here, n. N means total observations. Please look here, 1, 2, 3, 4. The 4 columns are there. And rows you count, 1, 2, 3. 4 into 3. Look here, n equal to 12, you can write. And rows, look here, rows. First row, second row, third row. 3 rows are there. R equal to 3, you can write. And columns, look here, first column, second column, third column, fourth column. Means C equal to 4. Columns you can write. Okay, then we can go to the next. Look here. State the hypothesis. Hypothesis you have to state. H0. H0 means null hypothesis. The mu1 equal to mu2 equal to mu3 equal to mu4. Why I have taken, look here. Now 3 rows are there and 4 columns are there. You have to state the hypothesis for the rows and columns separately, so that I clubbed them. You take whichever is more. Suppose rows are more or columns are more, you take that only into the consideration. 4. The columns are more, therefore you take the mu1 equal to mu2 equal to mu3 equal to mu4. For the rows, what happens? Mu1 equal to mu2 equal to mu3. It becomes for rows verification. And null hypothesis, opposite of this. This is equal to, not equal to, equal to, not equal to, equal to, not equal to. Okay. Now, at least one. This, all these 3 may not be equal. At least if one is unequal, it is okay. Then next calculation. CF t square upon n. Look here, t square upon n and t value. Look here, t value you are getting here and n value you are getting here. 12. That this t square divided by 12 you can take and calculate. This is what CF you write here. And TSS, summation of xi square minus CF. Now, summation of xi square I want. Look here, summation of xi square. This value you are getting. You take that value and write it here. And CF, already you have calculated the CF here. You can take a minus CF and find out. And SSR, summation of a TI square upon Ni. Look here. Ti square. Look here. Ti square, this value, divided by Ni. Ni means 1, 2, 3, 4. 4 values. This Ti square is a sum of 4 values. And therefore, Ti square divided by 4 you can take. And similarly, here, T1 square divided by 4. T1 upon N1. Then this value divided by 4. And similarly, this value divided by 4. Plus this value divided by 4. You can write here. See here. And minus CF, CF is already here. You take a minus CF. You calculate. SSC, summation of Pi square upon Ni. This is also from the table. Look here. Summation of the look here, Pi square, this value, look here. This value divided by, look here, 1, 2, 3. This divided by 3. And this again divided by 3. And this divided by 3. This is summation of Pi square. Look here, this divided by 3 plus this divided by 3 plus this divided by 3. And minus a CF. Means the CF is already known to you. You can calculate this. Now, after calculation of this, you find out finally SSE. The SSE equal to TSS minus SSR minus SSE. You remember all these formulas are very important. Look here. TSS is already there. SSR is there. SSE. You can calculate this. You can calculate all these 5 values. And next, very, very, very important. This ANOVA table. Examiner gives marks by looking at this table only. If the table is correct, he won't see what you have done in earlier steps. Directly marks will be given. Look here. This is variations, degrees of product, sum of squares, SS, and mean sum of squares, and F value. Then look here, rows, columns, error, total. Degrees of product. For the rows, R minus 1. R minus 1. How many rows are there? Minus 1. Look here. How many rows are there? Minus 1. Look here. How many rows? 4. 3 rows. 3 minus 1. And similarly, column C minus 1. You can write there. Look here. C minus 1. In the table. Look here. C minus 1. That is degrees of product. And error is R minus 1 into C minus 1. This into this. You have to write here. And N, total, means capital N. Total observations. Look here, total observations. See here, total observations. 12 observations. 12 minus 1. You are getting N minus 1. Then SS. SSR. Look here, SSR. See here, SSR value. And SSE value, SSE and TSS. All these values you can enter there. Look here. SSR, SSE, 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 TSS. You can enter. Already calculated there. And look here. This is calculation. MSS. MSSR equal to SSR divided by R minus 1. Look here. SSR divided by R minus 1. This value divided by this value. Look here, this value divided by this value. You can get MSR value. MSC, SSC divided by C minus 1. Look here, SSC divided by C minus 1. You make a calculation and write here. And similarly, MSC, SSC divided by R minus 1 and into C minus 1. Look here, this value divided by this. You can get MSC. Then F equal to FR. Or look here, MSR should be divided by MSE. MSC should be divided by MSE and divided by MSE. Look here, FR equal to MSR divided by MSE or MSE divided by MSR. By suppose MSE is greater than MSR, you can use this second formula. If MSR is greater than MSE, you can use the first formula and calculate the FR. Similarly, FC. MSC, look here, MSC divided by MSC, if MSC is greater than MSE. Suppose MSC is greater than MSC, then you can use this formula. and look here, F, R, and degrees of freedom you can mark. Look here, if you use this formula R minus 1, the here, the MSR, its degrees R minus 1, and MSC, its degrees R minus 1, C minus 1. You can mark here. And they becomes mu1 and mu2. Look here, R minus 1, mu1. R minus 1 into C minus 1, mu2. This is useful to find the stable values. Okay. Then similarly, FC, you can mark mu1 and mu2. Look here. For the MSC, here C minus 1. And MSC, R minus 1. Suppose this is greater, that is means you can take here it becomes mu1. Okay. If MSC is greater. Then FT at 0.5 with the degrees of freedom. Look here, degrees of freedom. The mu1 equal to u r, this is mu1 and mu2. See the table and find the value. And compare this value with FR value. Look here, FR and FT. Whichever smaller or greater, you check. Suppose FR is smaller than FT. FT means stable value. Then H0 is accepted. Suppose FR is greater than FT. Then H0 is rejected. Then similarly for the columns also. FT at 0.05 with the degrees of freedom, the mu1 and the degrees of freedom, mu2. You find this value from the table, log table. Then compare FC means calculated value of the column and table values of the F, table value. If FC is smaller than FT, then H0 accepted for columns. And FC is greater than FT, then H0 is rejected for column. Okay.